In this video, we take a look on how the electrons in a scanning electron microscope interact with our sample and what information we gain from that. And maybe you remember something about wave-particle duality. For example, in a transmission electron microscope, the electrons behave as a wave. But in the scanning electron microscope, they behave as a particle. So that is the first thing you need to know. And how do these electron particles interact with our sample? Well, our sample consists of electrons as well. That means we kind of play pool here. Therefore, first interaction we will experience is collision. One ball hits another ball if we keep the pool game idea. A more scientific way to describe it would be inelastic scattering. The electrons that are emitted from this process are called secondary electrons or SE electrons, and they are low energy, only around 50 electron volts. Then we have something we can call rebound. A ball hits the wall of the pool table, or elastic scattering if we use a more scientific language. The electrons that we can detect from this process are called backscattering electrons or BSE electrons. The last thing that might happen is replacement and emission. Kind of like you accidentally shoot a ball into the stomach of your friend, the water glass slips out of his hands and water splashes out. The splashing of water, that's the X-rays that you can detect. Secondary electrons contain information about the topography of a sample. But when your material consists of multiple elements and you want to know how they are distributed, then you use the BSE electron image for that. And if you finally want to know which elements that are, then you look at the X-ray spectrum. Before we take a closer look into SE electrons, BSE electrons, and characteristic X-rays, you might want to refresh your knowledge on Bohr's model of an atom, or maybe also the basics of what characteristic X-rays are. Links for both videos are in the video description. Now, secondary electrons. We already know how they are produced. The keyword is inelastic scattering. What means energy is lost. But what information do secondary electrons contain? In this picture, we can see a surface which we might want to analyze. Electron beam number 1 that hits the surface near the slope will result in a higher number of SE electrons that reach the detector, and therefore this area will appear brighter in the resulting image as location 2. Remember that secondary electrons are low energy. That means that they contain only information about the top 100 nanometers of your sample. Very surface sensitive. Backscattered electrons are next on our list. Here we have elastic scattering, which means that kinetic energy is preserved. They have a very high energy, nearly the kinetic energy of a primary electron, which is also why they carry information from 1 to multiple micrometers deep into the sample. Not surface sensitive. However, the correlation between detected BSE and atomic number Z is very high. That means we can create material contrast images which contain information about the distribution of different elements. With what I told you now, which image is a SE image and which one is a BSE image? The image on the left-hand side contains much more information about the surface structure or topography. Surface sensitive means it's an SE image, whereas the image on the right-hand side contains less topographical information. Of course, it's a BSE image. Instead, you see these bright dots which you can't see in the SE image. It looks like our sample contains atoms with lower atomic number compared to the surrounding matrix. To find out the identity of these two different materials, we need to take a look at the characteristic X-ray spectrum. I hope you still remember the analogy about shooting your friend into the stomach while playing pool. Now, what actually happens is that a primary electron hits any electron in the atom which gets released. What remains is a vacant spot that can be filled by an electron from a higher energy level. The energy difference is released in form of X-rays which can be detected. What we finally get is a characteristic spectra that contains information about the chemical identity of our sample. Besides the characteristic X-rays, we also capture the so-called Bremsstrahlung. That is radiation which is produced from deceleration of charged particles in any material. Okay, that's it for today. A lot of very important information. Thanks for watching and see you in my next video.